So given a probability distribution, we can calculate the expected value, which is what we would expect the average to be if we repeated an experiment many, 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 many times. And so just like we can take that theoretical mean, that expected mean, if we repeated the experiment many times, we could also calculate the theoretical standard deviation. Okay? And the formula for standard deviation is similar to the formula that we already have gone over, but we adjust for the fact that we're dealing with probability. So we look at how far each outcome deviates from that expected value. We square it, so we really are just looking at the distance and not the direction. We multiply by the probability. This is the part that's different. This is instead of dividing by n. Okay? We multiply by the probability because some outcomes are more likely to happen than others. We add it all up, and then we take the square root of it all to correct the square that we took earlier. Okay? So this is just the standard deviation. It's standard deviation. It is the average amount or the standard amount we would expect outcomes to deviate from that expected value. The theoretical average or standard amount, outcomes of repeated experiments would deviate from the expected value, that mu, over the long term. So we can use this standard deviation to tell us, well, are the outcomes, will they generally tend to stay pretty close to that expected value? Or if we kind of list all the outcomes out or put them in a graph, they're going to be more spread out. That's what this standard deviation tells us.